Welcome to a slow, beginner-friendly lesson on Python sets, made for absolute beginners. Uniqueness begins. Today we meet a new Python collection, the set. Until now, you gathered values in lists, where order matters and duplicates are allowed. A set is different. It stores unique items only, with no order, no duplicates, and no indexing. You might wonder, why would you want that? Because sets are exceptionally fast at one question: is this item inside? Membership testing is the set's superpower. We answer what a set is today, and save the deep operations for the next lesson. The set's superpower. A set is a Python collection that stores unique items. Imagine a bag where each item can appear only once. If you try to add a second copy, the bag ignores it. Sets use curly braces, like dictionaries, but without the colons. The items inside have no order, no indices, and no duplicates. What you get in return is something powerful. Asking whether an item exists inside is extremely fast. Sets are designed for one job: holding unique things and checking membership quickly. Unique items only. Until now, you stored items in order. A set changes the rules. What matters is whether something is inside, not where it sits. A bag of distinct things. A set looks simple from the outside. Items sit inside curly braces, separated by commas. But the rules inside are strict. There is no first item, no second item, no third item. The very idea of position does not exist. There are no duplicates. If you try to add apple twice, only one apple remains. The items are unique, unordered, and unindexed. Think of a set like a bag of distinct marbles. You can ask whether a marble is inside, but you cannot ask for the third marble. No position, no duplicates. Duplicates vanish the moment they enter a set. The collection keeps only one of each, automatically, with no extra code. Here is the basic syntax. You create a set with curly braces, fruits equals apple, banana, cherry inside braces. Notice that when Python prints the set back, the order may differ from what you typed. That is normal. Sets have no guaranteed order. Len of fruits gives 3, because there are 3 unique items inside. The braces look like a dictionary, but there are no colons inside. That is how Python tells a set apart from a dict at a glance. Curly braces, no colons. Watch what happens with duplicates. Tags equals Python, code, Python, docs. You wrote Python twice, by accident or on purpose. When Python builds the set, the duplicate is silently removed. The resulting set has only 3 items: docs, Python, code. Len confirms 3, not 4. This is the first rule of sets: uniqueness is enforced automatically. You never have to check for duplicates yourself, the set handles it for you the moment you create it. Uniqueness is automatic. Once an item is already inside a set, adding it again does nothing. There is no error, no warning, no second copy. The set simply ignores the request. This silent behavior is intentional. The whole point of a set is to guarantee uniqueness. If you keep a list and try to remove duplicates by hand, the code gets long and slow. A set does it for free. The trade-off is that the order of items may shuffle every time the set is built or modified. You must never rely on position. Silent by design. You cannot index a set. Fruit square brackets 0 raises type error. Sets are not subscriptable. There is no 0th item, no first item, no third item. If you need to walk through the items, you use a for loop, but you must accept that the order is whatever Python decides. Look at the output: cherry, apple, banana, not the order you typed. If order matters to your program, a set is the wrong choice. Use a list instead. No 0th item. Order in a set is an implementation detail, not a promise. The same set may print in a different order on different Python versions, or even after you add and remove items. You must never index into a set, never slice it, never write code that depends on which item comes first. What the set gives you in return is uniqueness and blazing fast membership checks. The trade is clear: you give up order and indexing, and you get back speed and the guarantee that every item appears exactly once. Order is not a promise. Membership testing on a set is nearly instant, even with thousands of items inside. Speed is the reward for giving up order. Speed is the reward. Membership testing is where sets shine. You ask Python in tags, the answer is true. You ask Java in tags, the answer is false. Not in works the same way, flipped. The keyword in works on lists too, but on a list Python has to walk every item one by one. On a set, Python jumps straight to the answer using a hash table under the hood. For a few items it does not matter. For thousands, the difference is enormous. Sets turn slow searches into instant answers. The in keyword. Why is membership so fast on a set? Think about a list. To answer is X in the list, Python walks every item until it finds a match, slow for thousands of items. A set uses a hash table, a structure that jumps directly to where the item would live. The check takes the same time whether the set has 10 items or 10 million. That is the set's superpower. When your program asks, is this user already in the group thousands of times per second, a set is the right tool. Hash tables jump straight there. Sets come straight from mathematics. Union, intersection, difference, these are not new ideas, just old friends in Python form. Old friends from mathematics. When you work with a set, 4 kinds of operations come up. You add an item with the add method. You remove with remove or discard. You test whether an item belongs with the in keyword. And you combine 2 sets using mathematical operations, union to merge them, intersection to find what they share, and difference to find what one has that the other lacks. These last 3 come from school mathematics. Today we preview them, the next lesson goes deep on each. Add, remove, test, combine. Here is a first taste of set operations. A equals 1, 2, 3. B equals 3, 4, 5. The pipe symbol gives the union, every item from either set, with duplicates removed, so 1 through 5. The ampersand gives the intersection, only the items both sets share, which is 3. The minus sign gives the difference, items in A but not in B, which is 1 and 2. These symbols come straight from mathematics. We go deep on each in the next lesson. Pipe, ampersand, minus. How does a set compare to a list? A list is ordered, first, second, third. It is indexed, you can ask for position 0. It allows duplicates. But searching a list is slow, because Python walks item by item. A set flips every one of those traits. It is unordered, unindexed, and rejects duplicates. What you gain is instant membership testing. Choose a list when order or position matters. Choose a set when you need uniqueness or you keep asking, is this thing here? Different tools, different jobs. Here is one of the most common uses of a set, removing duplicates from a list. Names equals Ada, Grace, Ada, Linus, Ada appears twice. Wrap the list with set, and the duplicates vanish. If you need a list back, wrap that with list. But be careful, the order is not preserved. The cleaned list comes out in whatever order Python prefers. If you need to keep the original order, you need a different approach, which we cover later. For simple uniqueness, set is the fastest tool. A classic Python trick, where do sets show up in real programs. Tags on a blog post, each tag is unique, order does not matter. Countries a user has visited, a membership list, no duplicates. Members of a club, you ask is Ada a member, and the answer comes back instantly. Unique words in a document, drop the duplicates and you have the vocabulary. Anywhere you need a collection of distinct things, where the question is this one inside rather than what comes first, a set fits naturally. Sets are everywhere. Choosing between a list and a set comes down to one question: do you care about order, or do you care about membership? Order or membership? When should you reach for a set? 4 signs. You need unique items, duplicates are not allowed. You test membership often, your code keeps asking, is this thing here? Order does not matter. You want to combine collections mathematically, union, intersection, difference. If any of these matches your problem, a set is probably right. If order matters, or you need duplicates, reach for a list instead. Choosing well gets easier with practice. 4 signs to watch for. Quick self-check. Can you explain in one sentence what a set is? Can you name 3 things a set does not have: order, indices, duplicates? Can you explain why membership testing is fast? Can you name one practical use, like removing duplicates from a list? If any feels shaky, rewatch the matching part. You do not need to memorize the operations yet, the next lesson covers them in depth. Hold the big picture: unique items, fast membership, mathematical combinations. Say each out loud. In one breath, a set is a collection of unique items with no order, no indices, and no duplicates. What you give up in structure, you gain in speed. Asking is this item here is one of the fastest operations in Python. Sets also unlock mathematical combinations, union, intersection, and difference, letting you merge and compare collections in a single line. When your data is naturally unique, and the question is membership, reach for a set. The next lesson shows the operations in depth. Unique, unordered, fast. What comes next? The next lesson is the deep dive on set operations. You will learn to add items, remove items safely, and pop items off the set. You will use union, intersection, and difference with many code examples, and meet the methods that match each symbol. You will also meet the frozen set, a set that cannot change after creation. For today, hold the foundation. A set is unique, unordered, and built for membership. Operations are next. If you want a quick practice, open IPython and create a set called visited, with 3 countries. Ask Italy and visited, the answer is true. Add Germany with the add method, len now gives 4. Try adding Italy again, len still gives 4, because duplicates are silently ignored. 5 lines, 3 ideas: create, test membership, add safely. When that feels comfortable, you are ready for the operations deep dive in the next lesson. Create, test, add. Thanks for meeting the set. Next we explore its operations in depth. The set is yours.